Hello and welcome back students to the next module of the chapter where we'll be basically focusing on standard enthalpies of formation, combustion and neutralization. Let's take the first one, that is standard enthalpy of formation, represented as delta H naught of F, that means formation. The definition says that whenever 1 mole of a particular compound is formed, it has to be formed in its standard state and it has to be formed from its element also in their standard state. Now what does it mean? Let's take an example, that is formation of 1 mole of water having a formula H2O. So if you have to form 1 mole of water, we have to form from its elements only, and the elements are hydrogen and oxygen, which are diatomic. So H2 gas will react with O2 gas. Now since it is formation of 1 mole of liquid water, we cannot change the balancing part of water. So the equation will become as 1 H2 plus half O2 will give you 1 mole of H2O. Only in that case, the delta H value, that is minus 286 kilojoule per mole, is applicable. Let's take one more example, that is formation of 1 mole of ethane gas. Ethane is having a formula C2H6. Now if it is getting formed, it will be formed from its elements, and the elements are carbon and hydrogen. So can I say carbon solid will react with hydrogen gas to give you C2H6, that's ethane. But since it is formation of 1 mole of ethane, we cannot change the balancing of ethane. So the equation will become as 2 moles of carbon will react with 3 moles of hydrogen to give you 1 mole of ethane. Only then the delta H value, that is minus 104.58 kilojoule per mole, is applicable. So this is enthalpy of formation. Let's take the second one, that is enthalpy of combustion, represented as delta H naught of C. It also says that whenever 1 mole of a substance is undergoing combustion, it will entirely substance will basically get burnt, which is there. Now what does that mean? Let's understand that with the help of an example. If it is combustion of 1 mole of methane, combustion reaction means reaction with oxygen, and methane having a formula CH4. So we'll have the reaction as CH4 plus oxygen will give you. Now can I say it is nothing but a combustion of hydrocarbon? And we have done in our lower standards that combustion of hydrocarbon will always give you carbon dioxide and water. Now since in this reaction it is combustion of methane, we cannot change the balancing part of methane. Only in that case we can change the balancing of rest all the other terms except methane, and the answer which we will get after the balancing as 1 mole of methane will react with 2 moles of oxygen to give you 1 mole of carbon dioxide and 2 moles of water. Only in that case the delta H value, that is minus 890.4 kilojoule per mole, is applicable. So it is strictly for 1 mole of methane. Let's take one more example. It is combustion of 1 mole of carbon monoxide. Now carbon monoxide is nothing but CO, combustion reaction with oxygen. So can I say it will give you the answer as carbon dioxide. Now since it is combustion of carbon monoxide, we cannot change the balancing part of carbon monoxide. Then in that case the equation will become as 1 mole of carbon monoxide will react with half moles of oxygen to give you 1 mole of carbon dioxide. Only in that case the delta H value, that is minus 283 kilojoule per mole, is applicable. Here there is an exception, and the exception is nitrogen and fluorine. Generally, it has been seen that all the combustion reactions are exothermic, whereas nitrogen and fluorine are the only 2 components whose answer is positive. Let's take the last one, that is enthalpy of neutralization. Say for example, if we consider an acid and a base like HCl and NaOH, they will react with each other to give you NaCl plus water. That means 1 mole of HCl will react with 1 mole of NaOH to give you 1 mole of salt and water. Only in that case the answer is minus 57.3 kilojoule per mole. This is very important, and generally the neutralization reactions are also exothermic. That means heat is coming out from the system which is there. And a very important point to remember is that is heat of neutralization of strong acid and strong base is always a constant, and its value is 13.7 kilocalories or 57.3 kilojoules, which are there. But there could be an option. Every time the reaction won't have strong acid and strong base. So the possibilities are the acid and base both could be strong, or one could be weak and one could be strong, or both of them could be weak. We know the answer of only strong versus strong. So the highest answer is for strong versus strong, and the lowest answer will be for weak versus weak. Let's take that with the help of an MCQ. The first question says heat of neutralization of NH4OH and HCl is. Here we have to basically identify one of the component is strong or weak or how. Can I say in this question that is HCl is a strong acid, NH4OH is a weak base, then in that case it is a reaction of strong acid and weak base. That means somewhere the answer will be less than 13.7 kilocalories per mole and the option is B. Second question says the mutual heat of neutralization of 40 grams of NaOH and 60 grams of acetic acid will be. Let's see once again the type of acids and bases which are given. NaOH is a strong base and acetic acid is a weak acid which is there. So can I say once again there is a reaction between strong versus weak, and once again we know the answer that whenever the answer will be strong versus weak, somewhere the answer will be less than 57.3. That's option B. The third question which says that which of the following reaction can be used to define the heat of formation of carbon dioxide? It has to be formed from its element, and the elements are carbon and oxygen. So option A is wrong because benzene is used. Option B is wrong because methane is used. Option C is also wrong because carbon monoxide is used, and that is why the correct option is option D because it is forming from its elements. And the last question which says that hydrogen plus iodine giving you 2 moles of HI and the delta H value is given that 12.4 kilocalories, and according to this equation or this reaction heat of formation of HI will be, to be specific, I repeat the question, HI, that is 1 mole of HI. If in the reaction 2 moles of HI is giving you answer as 12.4, then 1 mole will be answer will be exactly half, and the answer is D, that 6.20 kilocalorie. This is what we'll be doing in this module. Thank you.